Hi everybody, in this video I'm going to go over APEX section 10.3.1, which goes over an introduction to optics. Now I've broken this study section into 3 videos, so this is just the part 1 video. And in this part I'm going to go over refraction and reflection, okay? So here we go. Refraction occurs when you have light that is going from one material to travel through another material. And we've talked a little bit about this before. So if this is our surface between 2 different materials, I'm going to draw a line that is perpendicular to this surface. So let's say this is going from like air into water. Okay. So you could have your light traveling in from the air, and then when it reaches the barrier, the light bends. This is why if you look into water and you see like a fish or something in there, it's going to be not quite where you expect it to be because the light actually bends, okay? And that is called refraction. Now, there's a way that we measure this, and we call this the Index of Refraction. Okay, what the Index of Refraction is, and we abbreviate it as N, is it compares the speed of light in a vacuum to the speed of light in different medium, okay? So we talked about the speed of light is always the same in a vacuum, but it can change if light is traveling through a different medium. Okay, so the index of refraction in a vacuum is equal to 1. And everything else is going to be higher than that. And the higher your index of refraction is going to give you a slower speed of light. Okay, so this is a way that we compare these two quantities. And so this situation where we have air going into water, air has a lower index of refraction and water has a higher index of refraction, okay? And we can also look at this angle here, the angle that the ray of light makes with that perpendicular line that I drew, okay? And in this case, when you're going from a lower index of refraction to a higher index of refraction, you get a smaller angle. So that theta decreases when you're going from lower to higher, okay? We could also have the opposite situation, okay, where we're gonna draw, again, our barrier. And if this has a higher index of refraction, like let's say glass, and this has a lower index of refraction, let's say it's going to air, then the opposite is going to happen. You're going to have a smaller initial angle of refraction, and then it's going to get larger. So in this case, the angle increases. Okay, and if you study this, there is actually a pattern that you end up seeing, and we can call this pattern Snell's law. And what Snell's law says is that N1 times the sine of theta 1 equals N2 times the sine of theta 2. So what that means is the index of refraction times the angle of refraction of your first material is going to be equal to the index of refraction times the sine of the angle of refraction for your second material, okay? And this allows us to make some predictions about the angles at which your light will bend. So let's do an example of that. So here we have an example. In a glass of soda, light travels from soda to ice. The light enters the ice at 15 degrees. What angle does it bend inside the ice? So let's try and draw this. Okay, so this is our surface. And here is our perpendicular line. We have the light is traveling from soda to ice. So this is soda, which has n equals 1.38, and this is ice, which has n equal 1.31. Okay, so in this situation, we know we're going from a higher index of refraction to a lower. So that's like the last situation we just saw. A higher index of refraction to a lower. So your angle is going to get larger. So here we go, let's draw this. This is smaller and this is larger. And let's add our angles, theta 1 and theta 2. Very good. Now we know the light enters the ice at 15 degrees. So this is 15 degrees. What is the angle it bends inside the ice? So we're trying to find theta 2. So let's plug in. We have n1 sine theta 1 equals n2 sine theta 2. So n1 is 1.38 times the sine of 15 equals 1.31 sine of theta 2. We're trying to get theta 2 by itself. So let's start on the left, plugging into our calculator 1.38 times sine of 15. Make sure your calculator's in degree mode and you're going to get 0.36 equals 1.31 sine of theta 2. So now we want to get theta 2 by itself, so let's divide by that 1.31. And we get 0.27 equals sine of theta 2. Now, if you remember from trig how we get theta 2 by itself, so we say theta 2 equals the inverse sine of 0.27. And again, you can put that right in your calculator and you get 15.7 degrees Celsius. Okay, so what we do when we get these problems, it's very helpful to draw the problem first so you know which index of refraction goes with which angle. Then you plug right into that Snell's law equation. And that last step, remember, to get the theta by itself, you have to take the inverse sine. Okay, so this is refraction. There's a second thing that light can do when it hits a barrier, and that is reflect. This happens when you have indices of refraction that are very different, like in the case of a mirror. That's not straight. Let's try one more time. Okay. There we go. Okay. So I'm drawing my barrier. Let's say this is air and this is into a mirror. Okay. So we have our light. And our light is going to come in, and then it is going to reflect back out. Okay? We call this ray of light that is coming towards the mirror, this is called our incident ray of light. The light that is bouncing back off of the mirror is called your reflected ray. And if we draw that perpendicular line to the surface, to the mirror, we can get two different angles here, theta 1 and theta 2. So theta 1 is what we call our angle of incidence. It's the angle that the incident ray forms with a perpendicular line to the mirror. The theta 2 is our angle of reflection. And that's the angle that our reflected ray makes with our perpendicular line, okay? So these things are related, and they're related by something called the law of reflection. And what the law of reflection states is that the angle of incidence is equal to the angle of reflection. So in this case, theta 1 equals theta 2. So whenever you have a ray of light that is reflected off of a barrier like a mirror, you're going to have the incident ray coming in towards the mirror, the reflected ray coming out of the mirror. And if you draw a perpendicular line down the middle of your mirror, you're going to make these two angles, the angle of incidence and the angle of reflection. And what the law of reflection states is that these two angles are always going to be the same. So this is going to help us in the future solve some problems about mirrors. Okay? So what we need to know from this section is we need to understand refraction, what refraction is and what the index of refraction is. And we need to be able to use Snell's law to solve equations. Then we need to understand reflection, that if you have very different n values, then you're going to have your light reflected instead of bending in, okay? And then the law of refraction, law of reflection says that the angle of incidence is going to be equal to your angle of reflection. Okay, so this is part 1 of this 3-part section for this apex section. So come back tomorrow for part 2.